Hello friends, welcome to HP Vibrant Academy. In the last lecture we have discussed up to question number 10. So we will discuss question number 11 onwards in this particular lecture. So basically we are discussing the problems on the Gauss divergence theorem. So let's start our discussion. So what is given in question number 11? If C is equal to half of curl of B and B is equal to curl of A, then show that we have to show this particular expression. Okay, so let's start solving this. Okay, so what is given in question number 11? So this is the solution of question number 11. Okay, so we have C is equal to half of del cross B. Okay, and B is equal to del cross A. Okay, we have to show that half of triple integration along volume B, we have B square dV is equal to half of surface integral A cross B dot n cap into ds plus triple integration along volume B A dot C dV. Okay, so what we have seen in Gauss divergence theorem? So we have f dot n cap into ds along the surface S is equal to triple integration along volume V. So we have divergence of f dv. Okay, so let us take f is equal to a cross b. Okay, and from vector identity divergence of a cross b is equal to del dot a cross b. Okay, so del dot a cross b is equal to b dot curl of a minus a dot curl of b. Okay, so this is b dot del cross a minus a dot del cross b. Okay, and we have del cross a, the value of del cross a is b, so this is b dot b minus a dot, and del cross b here it will be 2c, this is 2c, so we can write this as b square minus 2 times of a dot c. This is the value of divergence of a cross b. Okay, this is the value of divergence of a cross b. Okay, so now let us replace f with a cross b. So this is equal to surface integral a cross b dot n cap into ds. This is equal to divergence of, sorry, this is triple integration along the volume V, and divergence of f, that is del cross del sorry let us place f is equal to a cross b. Okay, so divergence of a cross b, so this is del dot a cross b dv. Okay, so let us place the value of del dot a cross b. So this is equal to triple integration del dot a cross b, this is equal to b square minus 2 times of a dot c dv. Okay, so this is equal to surface integral a cross b dot n cap into ds is equal to, this we can write as volume integral b square dv minus 2 times of volume integral a dot c into dv. Okay, now let us multiply half both sides. This, let us multiply with half both side. This is half, so this 2 gets cancelled, so this is equal to half of triple integration along the volume b, this is b square dv minus triple integration along the volume b, this is a dot c dv. Okay, this is equal to half of surface integral a cross b dot n cap into ds. This is equal to, okay, let us further simplify this. So this is equal to this particular expression. So this is half of surface integral a cross b dot n cap into ds. Okay, let us further simplify this for getting the desired result. In the question we have to prove this particular expression. Okay, so let us take this particular term on the LHS side. Okay, and this we have to, actually we have to calculate this particular expression. So from here half of triple integration b square dv is equal to this plus this. This is equal to half of surface integral a cross b dot n cap into ds plus volume integral a dot c into dv. Okay, so this is similar to what we have to prove in this question. Okay, now let us discuss question number 12. Let us discuss question number 12. Okay, so what is given in question number 12? If phi is harmonic in V, then show that del phi upon del n ds, surface integral of del phi upon del n ds is equal to 0, where S is the surface enclosing V. Okay, so it is given in question phi is harmonic in V. Phi is harmonic in V. This means del square phi is equal to 0. Okay, and we have to show that del phi upon del n ds surface integral is equal to 0. So let us solve this. Okay, so phi is harmonic in V, then del square phi is equal to 0. So how we can further simplify this? So this we can write as del phi upon del n into ds, surface integral along the surfaces. This we can write as surface integral del phi upon del n cap dot n cap. This we can write as, we can write this particular expression like this one, del phi upon del n, because dot product of unit vector is 1 into ds. Okay, so this is similar to the expression for the Gauss divergence theorem. This f dot n cap ds surface integral is equal to divergence of f dv volume integral. Okay, let us further simplify this, and this is equal to del phi. Okay, this particular term, that is del phi upon del n cap, this is equal to del phi. This we can further simplify the surface integral del phi dot n cap into ds. Okay, so using Gauss divergence theorem, okay, so let us further simplify this. So this particular expression del phi upon del n del s surface integral is equal to this one. So we can write this as this is equal to surface integral as del phi upon del n ds is equal to surface integral del phi dot n cap into ds. Okay, so let us take this as f. Okay, so using Gauss divergence theorem, f dot n cap into ds surface integral is equal to triple integration divergence of f dv. Okay, that is del dot f. This we can write as del dot f dv. This is divergence of f. So this is equal to divergence of, that is del dot del phi dv, and this is volume integral. Okay, using Gauss divergence theorem. Okay, and this we can write as, this is equal to triple integration del square phi dv, and since phi is harmonic in V, then del square phi is equal to 0. So this is del square phi is straight away 0. So this is equal to 0. So this means this expression, that is surface integral del phi upon del n into ds is equal to 0. Okay, so this we have to show in the question. Okay, now let us discuss question number 13. So what is given in question number 13? Phi is harmonic in V, then show that phi of del phi upon del n del s is equal to triple integration del phi mod whole square dv. So this is similar to question number 12. Let us solve this. So what we have to, what is given in question? We have phi is harmonic in V. Question number 13. Phi is harmonic in V. This means del square phi is equal to 0. And we have to show that surface integral phi of this is phi of del phi upon del n into ds is equal to triple integration del phi mod whole square dv. This we have to show. Let us show this. Okay, so we have, let us simplify this expression. So this we can write as phi of del phi upon del n into ds surface integral. This we can write as surface integral phi times of del phi upon del n into n cap dot n cap into ds, because dot product of unit vector is unity. Okay, so let us take this as, this is on comparing this, let us take this as f dot n cap ds. On comparing this with Gauss divergence theorem, what is Gauss divergence theorem? F dot n cap into ds surface integral is equal to divergence of f dv volume integral. Okay, so this is equal to, and this is, and del phi upon del n into n cap is equal to del phi. So let us write down one step further. So this is equal to phi times of del phi, phi times of del phi, sorry, this is phi times of del phi, phi times of del phi dot n cap into ds, and this is surface integral. Okay, and this is equal to, using Gauss divergence theorem, this is divergence of phi del phi dv. This is volume integral, and this is equal to phi times of del phi upon del n into ds surface integral. Okay, so now let us further simplify this expression. Okay, so this is our scalar quantity, this is a scalar, and del of phi is vector, that is gradient of phi. Gradient of a scalar quantity is a vector quantity. So del of phi is a vector quantity. So what we have studied in vector identity, del dot phi of a, where a is a vector quantity and phi is a scalar quantity. So this is equal to del phi dot a plus phi times of del dot a, phi times of del dot a, and here a is equal to del phi. So let us replace this. So del dot phi times of del phi is equal to del phi dot del phi, okay, plus phi times of del dot del phi. Okay, and this we can write as del dot del phi is equal to del square phi. So let us replace this, phi times of del square phi, and since phi is harmonic in V, then del square phi is equal to 0. So this particular expression is 0. So this we can write as del phi mod whole square. So this is divergence of phi times of del phi. Okay, so let us replace this in this particular expression. So this is equal to del dot, sorry, divergence of phi times of del phi. This particular expression is del phi mod whole square. So this particular expression is del phi mod whole square. So this is del phi mod whole square dv. This is equal to triple integration along volume V. Okay, so we have this as, so this is equal to surface integral phi del phi upon del n into ds. Okay, so this we have to show in the question. Okay, so now let us discuss question number 14. Let us discuss question number 14. If phi is harmonic in V and del phi upon del n is equal to 0 on S, then phi is constant in V. So this is based on the question number 13. So let us write down the result of question number 13. Result of question number 13. So this is question number 14, solution of question number 14. So the result of question number 13 is phi times of del phi upon del n into ds surface integral. This is equal to triple integration along the volume V del phi mod whole square dv. Okay, and in question it is given as phi is harmonic in V. This is phi is harmonic in V. This means del square phi is equal to 0. Okay, and it is given that del phi upon del n is equal to 0, then show that phi is constant in V. Then show that phi is constant, phi is constant in V. Okay, let us solve this. Okay, so this is the result of, this is based on the previous result, that is of question number 13. So it is given in the question del phi upon del n. Del phi upon del n is equal to 0. So this particular term is 0. So this means volume integral del phi mod whole square dv is equal to 0. This means del phi mod whole square is equal to 0. So this means del phi mod is equal to 0. This means phi is constant in V. Okay. Okay, so since volume integral del phi whole square dv is equal to 0 based on the previous result, because del phi upon del n is equal to 0, this means del phi mod whole square is equal to 0 in V. This means del phi mod is equal to 0. This means divergence, gradient of something, gradient of phi is equal to 0. This means phi is constant. So phi is constant in V. Okay. So we have discussed up to question number 14. Okay. Thank you.